Dive in with us today as we explore more about currents and tides and how they are affected by weather or even affect weather. A current is a large mass of water that flows in a definite direction. Imagine getting in the water and looking up and realizing you're further down the beach than where you started. If a current is able to move you like that, imagine what else it could carry. Some things it could carry would be sediment and sand. There are two types of currents. There are surface currents and deep water currents. Currents are very important in many ways, but mainly they move sand and sediment down the coast from north to south, and they also have an effect on the temperature of the planet by bringing cold or warm water from one area to another. This water then affects surrounding environments. Surface currents can occur in the water from the surface all the way down to about 1,300 foot below the surface. This makes up about 10% of the ocean water. Surface currents are mainly caused by wind and waves. Other surface currents can occur further into the open water, like the EAC or the East Australian Current. These type of currents are generally formed a pattern of closed loops that turn clockwise in the northern hemisphere or counterclockwise in the southern hemisphere. Today we're going to take a look at some of the currents that can be found in the North Atlantic. We're going to start with the Gulf Stream. This current is coming from the equator, bringing warm water up the coast. This current affects the weather and brings warmth to the United States. The North Atlantic Drift Current travels across the top of the Atlantic and brings water from the east to the west of the ocean. This cools the water down. The Canary Current brings cold water down the east coast of Europe. This is why it is so much colder and potentially more rain in the United States. The Canary Current travels down to the equator, where it travels from the west to the east of the North Atlantic Ocean of the North Equatorial Current. This is where the water heats up and starts to cycle over again. These surface currents is what's caused with the formation of the Great Pacific Garbage Patch, which is a well accumulation of trash all in one spot. The East Australian Current does exist. It moves water from the north part of Australia down south. Unlike the EAC depicted in the movie Finding Nemo, the real EAC is 60 miles wide and 1 mile deep, so you can't really jump in and out of it. Ocean currents transport heat and cold thousands of miles over the oceans. These currents can carry warm equatorial water toward the poles and cold polar water towards the equator. Scientists are interested in these currents because they are critical to the animals that live in these areas. Next is deep ocean currents. These waters make up approximately 90% of the ocean. These currents are caused by density-driven forces and gravity. So what does density have to do with ocean currents then? At the Earth's poles, when water freezes, the salt doesn't necessarily freeze with it. So a large volume of dense, cold, salt water is left behind. When this dense water sinks to the ocean floor, more water moves in to replace it, creating a current. The new water also gets cold and sinks, continuing the cycle. Incredibly, this process drives a current of water around the globe. As the cold water moves up towards the equator, it warms up and rises, bringing the valuable nutrients with it, and then cools off and reaches the poles. There is only one deep ocean current called the global conveyor belt. It moves at only a few centimeters per second, making it take a drop of water 1,000 years to make the full revolution. Next, we will move on to our tides. Tides are the alternate rise and fall of the ocean that is caused by the sun and the moon. Tides are one of the driving forces behind surface currents. Celestial objects such as the sun and moon exert a force of gravity on the Earth's ocean and even on Earth. The force of the sun's gravity keeps the planets from flying out to space, and the moon's gravitational field stabilizes Earth so that it doesn't wobble around its axis, which would be a catastrophic for Earth's inhabitants. So next, we are going to get into our activity that explains a little bit more about how these tides work and how our cold and our warm water will mix around together. Stay tuned and have fun. Get ready to be active. Alright guys, so now that we've talked a little bit about currents and tides, we're going to do a little bit of a current experiment. So what you're going to need is 2 bottles, one filled with very warm water, one filled with cool water, and then we're going to use red for warm and blue for cool to represent our colors. And then you're going to need a laminated card or something that the water can't absorb through. So first off, we got to mix our colors. So we're going to take our cold first and put food coloring in it. Okay. We're going to put the lid on temporarily enough to shake it up and mix the color. Mix that color for me. And same thing with our red. We're going to mix the colors. Alright, and then once we got that, we're going to take the lids back off and we're going to set the blue one in our bin first. You're going to do this either outside or in a sink or a bin or something that doesn't matter if it does get wet because you're probably going to spill some water. So first thing that we're going to do is we're going to start with our blue on the bottom. That represents our cold water. And then our red is going to go on top and it's going to represent our warm water. So we're going to take and put our card on here, hold it nice and tight, flip it upside down, and put it on top of our blue. And then once you got it on there, you want to pull the card very quickly. You might want to have somebody help pull the bottom bottle so it doesn't slide, and pull the card very quickly and watch what happens. So if we look, our colors, are they mixing any? Nope, our blue staying blue and our red is staying red. So our hot water is always going to try to rise to the top, and our cold water is going to sink to the bottom. So that's what was one reason of our currents now. But if we do this in reverse and we set our red on the bottom, and we take our blue and do the same thing, so this time we're going to put our blue on top of our red. You can go ahead and hold that bottle for me. Okay, try to level it up, and then once you're ready, quickly pull that. Now if we watch what starts to happen this time, you're going to see some changes start to occur. So you'll notice that our colors actually begin to mix. And the reason that's happening is because our warm water is trying to work its way to the top, and that cold water is trying to work its way to the bottom. So if you feel, you're actually able to start feeling a slight temperature difference as that water is moving. All right. All right, guys, so we didn't really show you, we talked about some of our currents and tides, but another really cool activity you can do, and using that same water we just used for our other experiment, get you a clear baking dish. You could use an aluminum one too, but get you some form of a long kind of baking dish. Then you're going to use that cold water and that hot water, and you're going to use your food coloring. So you reuse that same water we just used if you didn't mix it too bad, or mix some fresh. And we're going to use some ice cubes. So what you're going to do is fill your container about halfway with that cold water. So you can dye it blue if you want. It'll help us to see it better. So take it and dye it about, or fill it about halfway full with that cold blue water. Next, we're going to mix in about a cup of ice or something so that we can make sure to get it really, really cold. And then if you want to, you can throw in some plastic sea animals if you want, or your ice cubes can just work. Whatever you want to do, make this a fun experiment that you can do. So next, you want to get water hot. You can get it boiling if you want, but that can be kind of dangerous. So just get the water really, really warm, enough that we can definitely feel that it's hot. And then mix red food coloring in with it, or another color, but red's going to work best for us to be able to see it. So mix in that water, get it red, get it warm. And then what you want to do is you want to slowly pour that warm red liquid into our cold. And you should notice something start to happening. So as we said, ocean currents kind of vary depending on what they are. But with that, you're able to see that warm and cold kind of moving around. Another thing that you can do too is if you have a kiddie pool outside or a regular pool outside, and maybe your parents have an air tank around, you can take and use that air nozzle to push water around different ways. So there's all different ways we can use to experiment with currents and tides and understand how our oceans work. So we talked a little bit too about how that water brings cool and warm water around and it affects our environment. Things like hurricanes, like we talked about a little earlier in the week, are also affected by these warmer waters, because when you get these storms over there, like hurricanes, and they're pulling up all that warm water, it's actually fueling that storm to grow stronger. Ocean currents have a significant impact on our weather. The greatest currents are well established, and they create flows that are set in motion by the Earth's rotation and winds. One of the biggest ways that our oceans are impacted is that it acts as a conveyor belt to bring warm and hot water around our Earth. So it goes great distances traveling water. And like we said earlier, sometimes a single water droplet can take 1,000 years to travel our whole cycle. But as it goes through warm, cold, and it just travels and cools and heats as it goes. So, as a wrap up with our currents and tides, we're going to talk a little bit more about how specifically our currents and tides affect our weather. The ocean actually plays a very important role in shaping our climate and our weather patterns. So, warm ocean waters provide heat and energy that actually fuel our storm systems. So did you know that warm ocean waters actually provide energy to fuel storm systems that will provide fresh water that is actually vital to all living things? So understanding and predicting precipitation is critical to farmers who decide when to plant crops or which crops to plant, how deep, and that's all based on part of the soil moisture. Crop and food prices may actually vary depending on the crop production that is based on how much water we may or may not get. So weather prediction can actually be a life-saving tool. It also helps us to prepare for catastrophic storms such as hurricanes and tsunamis. It can help citizens and governments anticipate extreme hot or cold temperatures. And waste management experts actually study rainfall so that they can manage the reservoir levels correctly.